Hello students, in the last video we have seen that when two waves from these two coherent sources of light start and meet at the screen, then they produce this bright or this darkness, this brightness or darkness. These kind of fringes, which are interference fringes, are created. And we have seen the condition when this brightness is produced when the value of phi is 0 or even multiple of pi, and this darkness is produced when phi is odd multiple of half wavelength produced by these two sources of light. And that condition we can write here intensity on the screen will be equal to intensity due to 1 plus intensity due to second source, one source, then second source, plus twice the square root of product of the intensities from the two sources and multiply by cos of phi. So this was the actually condition which we have seen in last video. Now we want to analyze that what happens when cos phi and how intensity is related to the light amplitude of the lights emitted from these two sources. For that purpose, I will write this equation in terms of intensity formation. So maximum intensity will be maximum when this cos phi will be equal to plus 1. Therefore, in that case, it will be I1 plus I2 plus 2 I1 I2 square root of it. Because cos phi is plus 1 for maximum intensity, that means such brightness. And in terms of amplitude, we can write A1 square plus A2 square plus twice of A1 here and A2 here, because I1 square root is equal to A1. So here we can write this equation as A1 plus A2 whole square. So it means maximum intensity will be equal to the square of the sum of these two amplitudes emitted by these two sources. Here you can see here, because I have written this thing, because intensity is the square of amplitude. Okay, so I have used this expression here. Similarly, I minimum, that means this dark point will be there when this cos phi will be equal to minus 1. In that case, if it is minus 1, I will write I1 plus I2 minus, now I will get here minus 2 I1 I2 square root, which means it will be equal to A1 square plus A2 square minus twice A1 A2, which is the square of the difference of two amplitudes A1 minus A2 whole square. So this is the minimum intensity we will get on the screen. Now, under special conditions of coherent sources, if suppose if amplitudes are equal, that means if A1 is equal to A2, in that case you will find that A1 plus A2 whole square will be equal to A plus A whole square. That means twice A whole square. It means 4 times A square. But A square is intensity, therefore it will be 4I. Means it becomes 4 times intense. Intensity will be 4 times brighter as compared to this. That means you will get brightness here and this brightness will be 4 times more than the intensity of the any of the source, that is because A square is equal to here intensity, so 2 to the 4 it gives you 4 times intensity. And what will happen on the minimum point? Let us see. In that case, the I max, in this case I maximum will be equal to 4 times I, let us say this intensity, instead of saying A, let me say it is equal to A1 and A1, so it will be 4 times A, because both intensities are same, therefore I can write 4 times the intensity of any of the source, but it will be 4 times the intensity emitted by of light emitted by the source of light, coherent source of light. And what will be the minimum intensity? That we can find I minimum will be equal to, when both of these are equal, then A1 minus A1 square will be equal to 0. It means the minimum intensity will be I minimum will be equal to 0. So it shows that in case the amplitudes are equal, then the bright point will be 4 times more bright than the source of light, and dark point will be totally dark. So therefore, under these conditions, we can find this band of interference fringes, and it gives us mathematical explanation why do we get this kind of brightness and darkness on the screen. And the ratio of the, if the amplitudes are not equal, then ratio of maximum to the minimum intensity may be given by the ratio of maximum intensity to the minimum intensity may be given by like this: A1 plus A2 whole square divided by A1 minus A2 whole square. Means if A1 is not equal to A2, then in that case we will get the intensity distribution in the band like this. Further, we can write that if intensity on the screen will be the sum of intensity of first source, intensity of second source, plus twice the intensity square root of intensity of first and second with cos of phi. Now, if the intensities are equal or having same amplitudes, then the intensity may be written as I1 plus I1 plus twice this I1 will be I square, therefore I twice I1 cos of phi. And in that case we have 2I1 here, so I can take 2I1 common. I can write 1 plus cos of 1 plus cos of phi, which can be written as 2I1 cos square phi by 2. So the total intensity on the screen will be like this, and it will depend upon the now phase difference phi. If, let us say, phi is 0, or let us say 2 pi, then cos 0 will be 1, oops, I should write here 4, so let me write this point as, because I will get here 2 cos square phi by 2, and therefore 2 to the 4 I will get here 4 times I. So in that case I maximum will be equal to 4 times I1. As we get maximum here also, this is for I1 when amplitudes are equal. From this expression also we get the same, and it happens when phi is 0. It will happen when phi is 0, or you can say when 2 pi, or further 4 pi, and so on. But if phi is, let us say, pi or 90 degree, in that case I minimum will be equal to 0, because cos 90 will be 0 and everything will be 0. So I minimum will be 0, and it will happen when phi is equal to pi or 3 pi, or you can say 5 pi, and so on, odd multiples of pi. And if we draw the intensity curve here, then we will find, so this is the graph of intensity and phi. As I have plotted along y-axis, this is intensity. The height of this graph shows the brightness or the intensity. It falls towards this zone where phi becomes pi. When phi becomes pi here, then intensity reduces to 0. So that means you will get darkness here. Darkness means here you will have brightness in this case. Here brightness, then this will fall into darkness here. Then again at this point on other side also, when it is pi, then again it becomes black zone, and then you will get reddish zone here when the intensity is maximum, then again dark zone. So this way intensity distribution can be shown. Intensity distribution of the bright and dark fringes can be shown by using this mathematical relation. So this is how conditions of maxima minima can be obtained. So students, that's all for the conditions here of maxima minima in the interference pattern. In next video I will explain how to get the position of maxima minima on the screen by using mathematical technique. Thank you so much for watching this video.